Good morning, one and all. I hope everyone is doing good. Now, guys, let me begin the session associated with this module 3, that is the time response of feedback control system, where we had the session 1 and session 2 concepts. Now, with this session 1 and session 2 concepts, we had the basic introduction to the time response. Now, we understood what is time response of a feedback control system via two important responses. One is transient response and steady state response. Apart from understanding this transient response and steady state response, later we concentrated with the standard test input signals. Is it okay? Via step input, parabolic input, ramp input, and impulse input. We understood the different types of inputs available, and unit step input, unit ramp input, unit parabolic input, followed by unit impulse, along with the associated parameters of Laplace transforms. Is it okay? Those things we had it in the session 1. Now in the session 2, we concentrated with the time response analysis of first order system for unit step response. Is it okay? For unit step response and for first order system, and also for second order system. I think in session 2, we had the introductory associated with the second order system. Is it fine? Later we concentrated with the time response of second order system for unit step response, where we understood the detailed derivation of time response of second order system for unit step input in the form of C of t is equal to 1 minus e power minus xi omega nt divided by root of 1 minus xi square into sine of omega dt plus phi. That was the modified expression. Is it okay? Apart from knowing this derivation part in getting the expression, later we also concentrated with the time domain specifications via delay time, rise time, peak time, settling time, and maximum overshoot. Is it okay? Now, how about the delay time? It is the time taken by the response to reach 50% of the peak value. That is nothing but delay time. How about the rise time? It is nothing but the time taken by the response to reach from 10 to 90% or 0 to 100% or 5 to 95% of its final value. Is that okay? How about the settling time? Settling time, it is associated with the tolerance for 2% or 5% to reach the maximum value. And finally, we had the maximum overshoot. Maximum overshoot is nothing but the maximum value which response can able to reach. Is it okay? These are all the distinct time domain specifications what we concentrated so far. Now with the module 3, we will try to understand the time domain expressions for delay time, rise time, peak time, settling time, and maximum overshoot. Now, how about this session 3, the learning objective? The learning objective is to understand the concepts of time domain specifications of second order system for underdamped case. Now, how about the flow of content? Expression for TD and TR, that is delay time and rise time, followed by peak time, settling time, and maximum overshoot. Is it okay? First, let me begin with mathematical expression for delay time. Now, before we go for it, let me recall the expressions what we learned in the session 2, that is the second order system time domain response for unit step input. These were the two equations what we had. One equation was C of t is equal to 1 minus e power minus xi omega nt divided by root of 1 minus xi square into root of 1 minus xi square into cos omega dt plus xi sin omega dt. Later this was modified or simplified to one more expression, that is C of t is equal to 1 minus e power minus xi omega nt divided by root of 1 minus xi square into sine of omega dt plus phi. This expression has been obtained from this by using sin A cos B plus cos A sin B, that is sin of A plus B relation, where phi is equal to tan inverse of root of 1 minus xi square divided by xi. Is it okay? Now first let me begin with the delay time expression. As we are aware, It is nothing but it is defined as the time taken by the system response to reach 50% of the steady state output for the first time. And an empirical formula to find the delay time is given by this expression. That is 1.1 plus 0.125 xi plus 0.469 xi square divided by omega n, which is approximated as Td is equal to 1 plus 0.7 xi divided by omega n. And this is the expression what we use for evaluating the delay time. That is 1 plus 0.7 xi divided by omega n. This is for delay time. Next, we shall move on to the very important aspect, that is the rise time, expression for rise time. Now, how do we define this rise time? It is nothing but the time response of second order system. Strictly speaking, it is the time taken by the response to reach from 0 to 100% of its final value. Now, before we proceed with the parameters, first we need to have the time response of second order system for 100 ampere case. Is it okay? For unit step input, which is given by the generic expression. How about the generic expression? C of t is equal to 1 minus e power minus I omega nt divided by root of 1 minus I square into sine of omega dt plus 5. And this is the expression what we have. Is it okay? Now, how about this TR to reach from 0 to 100% of its final value? Thereby, next step, at t is equal to tr, that means we are interested in tr. How do I get tr? Provided when it reaches the maximum value is 100%. If I round it to, if I try to consider 100% as 1, thereby this, it reaches this maximum value. When it reaches maximum value, at t is equal to tr. Thereby, what the substitution I shall make? At t is equal to tr, c of tr is equal to 1. Is it okay? Thereby, C of tr is equal to 1 minus e power minus I omega n tr. Is it okay? Why? Because t has been replaced with tr divided by root of 1 minus I square into sine of omega d tr plus 5. Is it okay? Now, at t is equal to tr, C of tr is equal to 1. Thereby, this is equal to 1. Is it fine? Thereby, next step what happens, since C of tr is equal to 1, at t is equal to tr, now this it goes to LHS, 1 minus 1 is equal to minus e power minus I omega n tr divided by root of 1 minus I square into sine of omega tr plus 5. 1 minus 1 is equal to 0. Thereby, at t is equal to tr, exponential term cannot be 0. You please try to understand. Why? Because LHS is 0. When LHS is 0, if I try to equate this or if I try to simplify, this into this should be equal to 0. Is it okay? But practically, this exponential term cannot be 0. Thereby, the possibility is sine term can be 0. Thereby, sine of omega d tr plus phi is equal to 0, or we may able to simplify it as omega d tr plus phi is equal to sine inverse of 0. I repeat, if I try to have the product of these two terms is normally equal to 0, but exponential term cannot be 0, only sine term can be 0. Thereby, sine of omega d tr plus phi is equal to 0, or omega d tr plus phi is equal to sine inverse of 0. Thereby, what is the value of sine inverse of 0? 0 normally. When that sine inverse of 0 is 0, it is 0 for 0 value, pi, 2 pi and so on. What I mean to say is sine n pi is 0. Which means sine 0 is 0, sine pi is 0, sine 2 pi is 0, sine 3 pi is 0 and so on. Thereby, when do we have sine inverse of 0 as 0? For 0, 2 pi etc. until n pi. Is it okay? Next step, at t is equal to 0, C of t is equal to 0, which is the start of the system response. That is the initial thing. Hence, the first value of sine 0 is not considered for tr. Why? Because it needs to rise from 0 to 100%. Hence, further TR is defined as the time taken by the system response to change from 0 to 100% of the steady state output for the first time. Thereby, this expression, is it okay? Omega TR plus phi, I can't take it as first value. Is it okay? I need to go for pi. Why I can't take this as zero value? Why? Because at 0, TR, strictly speaking, C of t is 0. Is it okay? Thereby, I can't take this. I need to take pi. Thereby, omega TR plus phi is equal to omega TR plus phi is equal to pi, or omega dTR is equal to pi minus phi. Is it fine? Next, what is TR? We are interested only in TR. Thereby, TR is equal to 1 by omega d into pi minus tan inverse of root of 1 minus z square divided by z. Why? Because what is phi? Phi is tan inverse of root of 1 minus z square divided by z. Is it okay? Next step, what is omega d? Damped natural frequency, which is equal to omega n into root of 1 minus z square. Now, what is this sigma? This sigma is equal to 1 by t, which is equal to xi omega n. Is it okay? This is one more expression. Then finally, if I try to simplify this, like strictly speaking, omega d, this 1 by t or xi omega n, I may simplify in terms of sigma. Omega d divided by sigma is equal to root of 1 minus z square divided by xi. Actually, this is not so important. If you remember this expression, that is more than sufficient. Is it okay? That is, TR is equal to 1 by omega d. What is omega d? Omega n into root of 1 minus z square into pi minus tan inverse of root of 1 minus z square divided by z. Is it okay? Thereby, how about the expression for this? TR is equal to 1 by omega d into pi minus tan inverse of this. Instead of writing root of 1 minus z square into xi, I may write it as omega d by sigma. Is it okay? And this is the response output for different values of xi. This is for xi is equal to 0.6. This is for xi is equal to 0.8. TR1 first rise time, second rise time. And basically, rise time is a function of both sigma and omega n. From this expression, it is clear that rise time is proportional to sigma and also omega n. It is a function of both sigma and omega n. That means when rise time increases with respect to increase in the value of xi as shown in figure. That means when xi increases, rise time also increases. Is it okay? And this is the expression for rise time. 1 by omega d into pi minus tan inverse of root of 1 minus z square divided by z. Is it okay? From the point of examination, you can expect derivation of this rise time, peak time and other parameters. Thereby, you need to practice these derivations. Is it okay? This is concerned with the delay time and rise time. Next, I shall move on to the peak time. Now, before we go for the peak, now let me make use of the time response of second order, second order underdamped case output expression, that is C of t is equal to 1 minus e power minus j omega n t divided by root of 1 minus j square into sine of omega d t plus phi. Now at t is equal to tp, that means peak time, strictly speaking, at t is equal to tr, C of tr it was equal to 1. Wherein for peak time at t is equal to tp, to get the peak value, I shall differentiate this C of tp with respect to t and I need to equate that to 0. Why? Because to have the maxima value. Maximum value, how do I find? Through maxima relation. Now what is that maxima relation? It says the first order derivative of C of tp, it should be equated to 0. Is it okay? Now how about the value of C of tp? For C of tp, I need to replace t with tp in order to have peak time. Now if I try to do this, C of tp, what is this? It becomes omega n tp divided by root of 1 minus j square into sine of omega d tp plus phi. Is it okay? Next, in order to find the maximum value at t is equal to tp, I need to differentiate this with respect to t. Thereby, If I try to have do that, d by dt of this entire value 1 minus e power minus I omega n tp divided by root of 1 minus I square into sine of omega d tp plus 5. Is it okay? This differentiated value should be equated to 0. Now if I try to differentiate this, derivative of 1 is 0. Next, derivative of this root of 1 minus I square is constant. I'll take it outside. Then derivative, now I need to apply product rule. E power minus I omega n tp into sine of omega d tp plus 5. First, if I try to apply the product rule, first function into derivative of second function. First function is e power minus I omega n tp into derivative of sine, that is cos omega d tp plus 5 along with this omega d. Is it okay? Plus second function sine of omega d tp plus 5 into derivative of this e power minus I omega n tp, that is minus I omega n into e power minus I omega n tp. I think my point is clear. If I try to perform first order derivative, I need to apply product rule. First term into derivative of the second term plus second term into derivative of first term. Now in our case, first term is e power minus I omega n tp, second term is sine of omega d tp. Is it okay? After doing this, later I may take this e power minus I omega n tp, e power minus I omega n tp common. If I try to do that, e power minus I omega n tp divided by root of 1 minus I square. Is it okay? And like left out value, if I try to segregate this, minus I omega n into root of 1 minus I square cos of omega d tp plus 5 plus I omega n into sine of omega d tp plus 5 equal to 0. Is it okay? Next step, we shall simplify further. Now if I try to simplify this further, if we try to simplify, like we had this root of 1 minus I square, I may cancel out this. Is it okay? If I try to equate this to 0, this entire term, this term, it becomes 0. Now if I try to equate this to 0 as per this relation, this term can't be 0. Is it okay? Exponential term. Thereby this term can be 0. Thereby root of 1 minus of root of 1 minus I square into cos of omega d tp plus 5 plus I sine of omega n after taking omega n common. Is it okay? Right? Left out is xi sine omega d tp plus 5. And from this damping triangle, what we learned from session 2, this is the damping triangle. Is it okay? Now this is the opposite side and this is the adjacent side and this is the hypotenuse. Is it okay? What is sine phi? Sine phi is root of 1 minus I square. Cos phi is xi. Now based on that, what do I simplify? This root of 1 minus I square, I may write it as sine phi. And this xi, I may write it as cos phi. Thereby, this takes the form as such. This is sine phi. Is it okay? And after simplification, this it takes the form as sine of omega dt plus phi into cos phi minus cos of omega dt plus phi into sine phi equal to 0. After simplification, using sin A cos B minus cos A sin B, it results with this form sin of A minus B, and this it takes the form as sin of omega d tp plus phi minus phi equal to 0, where I may cancel these two terms, that is sin of omega d tp equal to 0 or omega d tp is equal to sin inverse 0. Now when we have sin inverse 0, what are all the possibilities we can have? 0, pi, 2 pi, 3 pi and so on. Is it okay? 0 I can't consider. The first value what I need to consider, the first peak occurs at pi. Thereby, the time at which the first overshoot occurs is at pi. Thereby, TP is equal to pi divided by omega d. ಏಕೆಂದರೆ ಇಲ್ಲಿ pi ಬರುತ್ತೆ. Sorry, omega d t pi is equal to pi. Thereby, what is TP? TP is equal to pi divided by omega d. In general, TP is equal to n pi divided by omega d. In general, in the sense, first peak, first overshoot, second overshoot, third overshoot, and so on. Is it okay? N, that is the generic term. Next, this is the generic value. TP is equal to n pi by omega d. Now, for n is equal to 1, 3, 5, so on for odd values, we have first, second, and third overshoots. What is that overshoot? In the sense, you can observe this from this waveform. Like we used to have this kind of decreasing and increasing parameters. Is it okay? Now, this practically speaking, this is overshoot. The maximum values what we have, those are all referred to as overshoot. These are all referred to as overshoots. And this minimum amplitudes, they are referred to as undershoots. Thereby, we have the possibility of getting both overshoot and undershoot. Is it okay? When do you have this first, second, and third overshoots for odd values 1, 3, 5, undershoots for even values 2, 4, 6. Thereby, depending on the requirement, overshoot or undershoot, I shall choose the value of n. Is it okay? This you need to understand it clearly, and this is the generic relation. TP is equal to n pi by omega d, and this n is chosen based on the overshoot and undershoot, either for the first, second, and third, and so on, with respect to odd and even values. Is it okay? And this is the expression for peak time. Now we learned the expression, how to derive expression for TD, how to derive expression for TR. Then we also learned how to derive the expression for TP, that is the peak time. Now next I shall move on to the settling time, that is TS. Now, as I told you, settling time is with respect to the tolerance band to reach the output with the maximum value. And we have the generic expression for the second order system, which is given by C of t is equal to 1 minus e power minus I omega nt divided by root of 1 minus I square into sine of omega dt plus 5. Since TS is measured around unity maximum value, is it okay? And negative sign of C of t can be discarded. Since this settling time is measured with respect to unity 1, this negative term of C of t can be neglected, and the remaining expression can be equated to a magnitude of 0.05. 0.05 is 5% tolerance, or 0.02 for 2% tolerance. Is it okay? I repeat, since TS is measured around unity, that is a maximum value, and this negative sign can be neglected, and left out expression can be equated to a magnitude of 0.05 or 0.02 for either 5% tolerance or 2% tolerance, depending on the requirement. Now, it is the exponential term that determines TS. Generally, settling time is determined by the exponential term, that is e power minus I omega nt, and not by the sinusoidal term. Hence, sinusoidal term can be neglected. This term can be neglected. I can neglect this. Is it okay? I can retain this in order to evaluate the settling time with a magnitude of 0.05 or 0.02. Then if I try to do that, e power minus I omega n ts, t is replaced by ts divided by root of 1 minus I square. This is equated to 0.05. Why? Because 5% tolerance, if I go for 5% tolerance. Or I may also equate this to 0.02 for 2% tolerance. Is it okay? If I try to do that, for next step, if I try to simplify this, I shall apply natural log on both sides. If I try to apply natural log on both sides, this exponential and natural log, it gets cancels. Left out is minus I omega n ts Is it okay? RHS, what we have? Only 0.05. Natural log is ln of 0.05. The value of natural 3x. This minus sign I can cancel. Finally, what we have? Xi omega n Ts is equal to 3, or Ts is equal to 3 by xi omega n. Is it okay? Next, for 2% tolerance band, the same thing we have, but instead of 0.05, I need to go minus 3.94 by xi. Ts is equal to 3 xi omega n, or Ts is equal to 4 xi omega n. Both can be considered, but in the problem, he specifies the tolerance band. Based on the availability of the tolerance band, you need to decide whether to go for 3 by xi omega n or 4 by xi omega n for 2% tolerance or 5% tolerance. Is it okay? And this is the expression for settling time, right? Next, I shall move on to the next. As t of t 1 minus cp divided by root of 1 minus xi square into sine of omega d t plus 5. What is maximum overshoot? It is defined as the value of the response at t is equal to t. That is the maximum peak value minus final steady state value. Now guys, from the figure you can observe this distance what we have. Is it okay? From 1 to this distance what you have, this is referred to as maximum overshoot. Now, how do I define this? How do I evaluate this mathematically? Maximum overshoot is evaluated as MP is equal to C of TP, maximum value minus 1, or C of TP minus C of infinity. Thereby, next step, MP is equal to C of TP minus 1. Now, C of TP in the sense, the same expression, I shall replace T with TP. If I try to do that, what we have? 1 minus e power minus I omega nt sine of omega dt plus 5. Minus 1, where I may cancel this minus 1 and plus 1. Is it okay? If I try to cancel minus 1 and plus 1, now what is left out over here? Now MP is available at this point. This is negative. Next step. But for the first peak overshoot, now what the parameter we had? TP is equal to pi by omega d. Is it okay? When do I get first peak? At n is equal to 1, thereby Tp is equal to pi by omega d. Next step, where and all we have this Tp, I shall replace it with pi by omega d, minus I omega n into pi by omega d. Is it okay? This is the replacement. Where and all we had Tp, that to be replaced with pi by omega d. This is because of first peak. Is it okay? This is the first peak of the overshoot. Next step, this is sine of omega d. Tp is pi by omega d plus 5. Where I may cancel this omega d and omega d. Is it fine? Later, this is e power minus I omega n into pi divided by omega n into root of minus I square, where I may cancel this omega n and omega n. Is it okay? Next step, after simplification, what we have? E power minus I this and this I may cancel, e power minus I pi divided by root of 1 minus I square into sine of pi plus 5. Is it okay? And this sine of pi plus 5, how do I write this? This is sine of 180 plus theta. 180 plus theta is minus sine theta, thereby this is minus sine 5. Now already we have minus of minus, what is it becomes plus. Is it okay? Next step, Since it becomes plus, next is left out only exponential term. Thereby, what does it takes the form? It takes the form as mp is equal to e power minus I pi divided by root of 1 minus I square. And this maximum overshoot is always expressed in percentage. Thereby, this I may write it as percentage mp is equal to e power minus I pi divided by root of 1 minus I square into 100. Is it okay? And this is the expression for maximum overshoot. Now you need to memorize the expression for TD, TR, TS, TP, and maximum overshoot. Now how about now let me make the review of the things what I covered so far. Now about the expression for TD. TD, this delay time 1 plus 0.7 xi divided by omega n. This is the expression for delay time. Is it okay? Next, if I go for rise time, how about the expression for rise time? TR is equal to 1 divided by omega d into pi minus tan inverse of root of 1 minus xi square divided by xi. That is the expression for rise time. Then how about the expression for peak time? Generic expression is n pi divided by omega d, wherein n it can take two distinct values, overshoot and undershoot. Based on the requirement of overshoot and undershoot, if I require overshoot, I need to replace it with the odd values. If I require undershoot, I need to replace with the even values. Is it okay? First overshoot, n is 1. Second overshoot, n is 3. Third overshoot, n is 5. Odd values. For undershoot, first undershoot, n is 2. Second undershoot, n is 4. ನೋಡಿ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ನೀವು ಅವ್ರು ಏನ್ ಕೊಟ್ಟಿರ್ತಾರೆ ಆ ಬೇಸ್ಡ್ ಅಲ್ಲಿ ನೀವು ಎನ್ ವ್ಯಾಲ್ಯೂ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಾಗ್ತದೆ. ಅವ್ರು ಏನು ಕೊಟ್ಟಿಲ್ಲ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ಫಸ್ಟ್ ಓವರ್ಶೂಟ್ ವೇರ್ ಐ ಮೇ ಟೇಕ್ ಪೈ ಡಿವೈಡೆಡ್ ಬೈ ಒಮೆಗಾ ಡಿ. Is it okay? That is defaultly. This is concerned with the peak time. Then coming to the settling time. Now about the expression for settling time, we had two expressions. Ts is equal to 3 by xi omega n or 4 by xi omega n based on the tolerance. If it is 5% tolerance, 3 by xi omega n. If it is 2% tolerance, 4 by xi omega n. Is it okay? This is based on the requirement we need to consider. ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಾರೆ ಟಾಲರೆನ್ಸ್ ಬ್ಯಾಂಡ್, ಆಮೇಲೆ ನೀವು ಡಿಸೈಡ್ ಮಾಡ್ಬೇಕಾಗ್ತದೆ. ಲೈಕ್ 3 by xi omega n ಯೂಸ್ ಮಾಡ್ಬೇಕಾ ಅಥವಾ 4 by xi omega n ಯೂಸ್ ಮಾಡ್ಬೇಕಾ ಅನ್ನೋದಕ್ಕೆ. Then maximum overshoot. Now this is C of TP minus 1. Then after simplification with the expressions what we had, and finally we had this maximum overshoot is evaluated using this expression. That is mp is equal to e power minus I pi divided by root of 1 minus I square. Is it okay? If it is expressed in percentage, what the value we used to have into 100. Is it okay? That gives the expression for maximum overshoot. Is it okay? Fine. And these are all the basic concepts associated with this second order system. Already we understood the concepts of first order systems, and these are all the concepts of second order system. Like with the one set, theory concepts has been covered. Is it okay? With the other set, from next class onwards, I need to take up the problems. First, let me concentrate with the problems on the first order system. Later, we will concentrate with the problems on second order system. Is it okay? Before we proceed with the problems, you need to know the expressions clearly. If you can know the expressions clearly, and also you need to be good in utilizing the calculator by changing the mode, degrees and radians. And if you can have those two things in mind, and if you have patience, no difficulty, you can able to get the correct answer for the given problem by substituting the parameters. Is it okay? Now, how about the learning outcome? The learning outcome is where we may understand and remember the concepts of time domain specifications of second order system for underdamped case. Now, what we are learning, this is for underdamped case. Why? Because xi is less than 1. Is it okay? That is delay time, rise time, peak time, settling time, and maximum overshoot. And these are all the reference textbooks. Is it okay? Hardly 1 minute is left out. The session session gets discontinued. And if you have any doubts, you please try to ask me, guys.